construction, tips and tricks with advanced design. My name is Evelina Palkanoglu. I'm Solution Technical Specialist in Greytech for Advanced Design. I'm also a structural civil engineer and I hold a PhD in computational mechanics from Loughborough University in the UK. Today, we will see why the stage construction is important to be considered when modeling any structural projects, and how you can take into consideration the construction phases in advanced design. First of all, let's talk about the stage construction. In conventional structural analysis, all loadings are applied at once on the complete final structure. However, in practice, structures are constructed in stages, story by story. And loadings such as self-weight, construction loads, and any finishing loads are present at each stage prior to structure completion. Additionally, concrete, especially concrete, is a time-dependent material, and sometimes the structural elements at certain stages are unmolded prior to reaching the concrete full strength. Hence, structural elements will have different concrete characteristics depending on their age in each construction stage. This is the reason, basically, why staged construction is important and why construction phases should be considered, especially when modeling structures that are primarily made of concrete, because the time-dependent properties of concrete might affect either positively or negatively the results, as we will see later on when we do the demonstration in advanced design. Stage construction analysis is not exclusive to new structures under construction. It can also be used for studying the effect of structural modifications on existing completed buildings, such as retrofitting work, changes in structural elements, and support conditions. So basically, what we will see today can be used on both new and old structures when it comes to modifications for the old structures. Schematically, we see on the bottom of this slide a 5-story concrete structure frame, and we can identify the 5 different stages according to the stage construction as automated by the software that we will see later on. In each stage, the load of the floor is applied, and we assume that the next stage, the first stage, is already deformed due to this load. That's why we see the load applied only on the floor that is the last one constructed. Stage construction in advanced design can be considered very easily. The software provides different tools that can automate the whole process. First of all, after establishing the different stages, the engineer needs to establish how many stages they would like to have. And you can either add the different elements on the stage you think they should be. This is the manual selection of stages. This type can be used for any structure that diverges from the typical multi-story building case, or, as mentioned earlier, you can use the automatic generation of phases and automate the whole process. So basically, the software in this case identifies the different stages according to the different levels of the floors, as we will see later on during the demonstration. When defining the construction phases manually, the user can select among different options as shown below. So basically you can, when adding, for example, when adding this highlighted beam, the beam highlighted in orange, in a stage you have the option to add this on the selected stage, on the selected stage and the next stages, or on the selected and the previous stages, or on all stages. So it's up to the user to define how the construction phases will be, or they will be taken into consideration when analyzing the structure. The solver allows for the calculation of its construction phase separately if the user wants to. So if you would like to see the results only on two or three different stages, the solver gives you this option. Otherwise, when selecting the full analysis and design, you get the results of the full model with all the stages applied. The content of its construction phase, as well as the results for its construction phase, and the full model can be easily accessed from the model tree by hiding and unhiding each stage accordingly. We can now move to advanced design to see how you can perform a stage construction in advanced design.
Moving now to the advanced design interface, we will see how the construction phases can be incorporated in the analysis and design of structures. I am going to create two different concrete frames. In the first frame, the construction phases will be considered, whereas on the second one, the whole frame is going to be constructed in one stage. So the whole point is to compare the results between those two frames, and at the same time we will see how easy and effective is to create a different construction phases within the interface of advanced design. The idea is to enable the different levels when creating this frame in order to allow the software to identify the different floors and create the different stages. So I am going to use the different subsystems advanced design provides in order to have the successful automation of the construction phases when using the automatic generator of construction phases. By enabling the levels, it's much easier to create the different structure elements, since you can just literally snap the different elements on the grid instead of needing 2 points to create the columns. Using the copy functionality, I can easily create more stories on this frame without having to create the same structure elements again. I can literally just copy them. It is important, however, to keep the correct subsystems. So each floor belongs to a different subsystem with the levels enabled. This is the last floor, the fourth. In order to make this slightly more interesting, I would like to add to the second floor up to the fourth floor a middle column. So So this is the second floor, this is the third floor, and this is the fourth floor. Now I am going to add the supports on this frame. I would like the supports to be on the first floor subsystem in order the software to identify them when creating the different construction phases. And I will ask for automatic generation of construction phases for this frame. The 4 different stages have been created, plus the full model, and we can see them. The stage 1 corresponds to the first floor. The stage 2 is the first floor already created plus the second floor. The third stage is the 2 previous floors and the third one. And the fourth is all the previous floors plus the fourth one. And obviously the full model has all of the floors on it. I am going now to create the same frame, but without adding any construction stages on it. So basically I will copy this frame, but without adding any construction stages. This is the second frame, and I need to add supports on that one as well. And we can see here that the second frame has not been assigned to any of those stages. In order to perform the analysis and not get any error message, it's important to create a construction phase for this frame, but we will ask all the structural elements to be created on the same phase. So this is the little trick in order to bypass any errors or warnings coming from the software. Because as long as you have enabled the construction phases, everything within the model needs to belong to some construction phases. Either you have multiple construction phases or just one for all elements. So in this case, I will perform the manual selection of construction phases. So I will ask this frame to be constructed all in stage 4. So then, when checking the different stages, on stage 1 we have the first floor of the left frame. On the stage 2 we have the first and the second floor of the left frame. On the third we have the previous 2 plus the third. On the fourth we have the fourth floor of the left frame, as well as the whole frame on the right hand side. And now I'm going to add the different loads. I will create the load combinations and I will perform the analysis in order to compare the results. So I'm going to add dead and live loads in this case, and I will keep the magnitudes the same, obviously, for both frames. We can see the loads now applied, and now I'm going to add the loads on different construction phases. So this is going to be performed manually as well. So the load on the first floor is going to be added on stage 1, obviously. The same for load 2 is going to belong to stage 2. This is the load for floor 3, and is going to be sent to stage 3. And the last one is going to be sent to construction phase 4. So when taking the different stages, we can confirm that each load corresponds to the selected construction stage. So on stage 2, we have the load that belongs to second floor, the third stage, and the fourth one where is the full model and the load only on the fourth floor. We will perform the same for the loads on the right frame. So basically, these loads need to be sent to the construction phase 4, as long as the whole frame is going to be constructed in one stage, and this is the stage 4. Since everything has been created and all the different stages have been assigned, we can now create the different combinations in order to run the analysis and reinforced concrete design. So I'm going to use the simplified combination generator to create the combinations for these two structures. And now I'm going to perform a finite element analysis plus a design. It's important to see that the software solver allows for calculation for different stages. So basically the user can decide if they want to run an analysis for the whole model or for a particular stage, and you have the option to select any of the stages provided. And if selecting the reinforced concrete design or the finite element analysis without mentioning which construction phase you would like to calculate, the software assumes that you would like to calculate the whole model. So basically, it will take into consideration that you have different stages, but you will get results for all of them. Whereas when you select this one, you get results only for the construction phase you asked the calculation for. So now I'm going to do a reinforced concrete analysis, a reinforced concrete design. And as you can see here, when plotting the deformed shape of these two frames, you can tell the difference between the beams of the first floor. So when adding the construction phases, we see that the beam of the first floor has deformed more compared to the beam on the right-hand side, where the deformation is almost half of this on the left-hand side. And obviously, we can see that as we climb higher and taking the second, third, or fourth floor, the deformation tends to become smaller and smaller. Whereas on the right-hand side, we see that the deformation, the deflection in the middle for all of the beams remains at the same levels. So basically, when adding the construction phases, you get more positive results when it comes to the upper floors, but you get really negative results in terms of the beam of the first floor, in this particular case of a frame. So you can see the construction phases can be either positive or negative in terms of the effect they have on the results. So it is nice to take them into consideration, because you might end up with a better design, not only a safe design, but also a more optimized design, for example. Taking forces now, I'm going to plot the bending moments for this frame. And as you can see here, the bending moments tend to have the same trend as the deflection, obviously. So we see that, not taking into consideration the construction phases, we end up having a lower bending moment on the beam of the first floor. So the user will calculate the reinforcement based on this value, which is not the true value after all, assuming that we have different construction stages. Whereas when it comes to the third and fourth floor, the user will perform the calculations, and the reinforcement that is going to be added on those beams is going to be much more than the requested, if we assume that we have different stages. So again, we see the same trend, we see the same point of adding the construction phases, because they can be either positive or negative on the results, and basically can affect the structural design. And it's nice to see the theoretical amount of reinforcement needed for this beam. So I'm going to select only the beams of the fourth floor, the ones that they seem to have the more difference between them. So as you can see here, the reinforcement required for those two beams, the theoretical reinforcement required for those two beams, is totally different, assuming that these two frames are identical. The loads applied to them they are the same. So basically, the effect of construction phases on those two beams is massive. So performing an analysis with the frame on the right-hand side, the user will add a great amount of reinforcement that is in essence useless, according to the second option, the left-hand side, where the construction phases have been considered and the load has been transferred properly to the different structural elements, and the time-dependent properties of concrete have been taken into consideration when doing the analysis. So this is a very important conclusion regarding the importance of the construction phases. And of course, this is obviously a positive thing, making your structural design more optimized. But on the other hand, we need to check this beam as well. The beam on the bottom, which is the one that will provide the negative result. So by selecting these two beams and checking again for the reinforcement, we will see that the amount of reinforcement requested is higher compared to the one requested on the right hand side. So basically, the beam on the first floor here, when the construction phases have been considered, tends to be highly stressed and develops higher stresses and forces and bending moments compared to the beam on the right hand side. And not considering the different stages, the user and obviously the structural engineer will end up with a design that is not safe at all. So basically, the structural engineer needs to take into consideration when designing a structure, when producing a project, if there is any need to have construction phases in the modeling scheme. And it's worth checking most of the time if the structure is quite sensitive to those type of procedure. So for example, concrete, it should be a material that always worth checking if the construction phases might change the results or might affect my design. But obviously, as I mentioned earlier, the construction phases does not apply only to new structures, new built ones, but on existing structures when there is some modification, when some propping is performed and some loads are changing, or there is an alteration on the structural system of the structure. So basically, having the opportunity to create the different construction stages within the advanced design gives the user such flexibility and also the freedom to have more tools in order to perform a safe and at the same time optimized design.
Finishing this session with some conclusions arised from the short demonstration presented earlier about the construction phases. The construction phases, when considered, affect the results significantly. You can see figure 1, where the demonstration profile of two different concrete frames is presented. And on the left-hand side, we have the frame where the construction phases were considered, whereas on the second one, on the right-hand side, the construction phases were not considered. And we saw earlier that both the deformations, the bending moments, even the reinforcement can be affected by the construction phases. So in some cases, the results are positive. As we mentioned, the beams on the upper part of the frame, third and fourth floor, whereas the beam on the first floor tends to be overstressed when the construction phases were considered. So basically, the design can be either optimized when adding the construction phases or safer. So it's very critical, it's very important for the structural engineer to assess the situation and take into consideration the construction phases when needed. It is mandatory to be used when designing a concrete structure. Yes, that's true. Concrete is a material whose properties tend to change throughout the time. Because it becomes from liquid to solid because of its solidification. So its strength, for example, its hardness, anything related to its mechanical properties tend to be higher when it becomes more solid. So it makes sense to take into consideration the construction phases when designing a concrete structure. However, the concrete structure is not the only structures that construction phases can be considered. As mentioned earlier, construction phases can be used for existing structure as well. So, for example, in the case of a steel structure where some propping is added, so there is some change on the structural system or some alterations on the loadings and how the load is transferred from the structural elements. The advanced design provides tools to automate the process of defining the construction phases, and the also exists the manual definition of construction phases in case there is a project that diverges from the typical multi-story building, and the construction phases needs to be added in a different way and maybe manually. And finally, the user has the freedom to define their own construction scheme in accordance with the individuality of each structural project, and of course they have the option to ask the solver to solve and calculate only the stage or the stages they want. Thank you so much for your attention, and I'm happy to see you again in any of our webinars. I'm happy to take any questions. Feel free to ask anything related to this webinar. Thank you so much again.